Scientific discovery has always been driven by curiosity. But access to the tools of discovery has not always been equal. For decades, the ability to perform advanced scientific work depended not just on knowledge, but on access. Access to expensive software, specialized systems, and institutional privilege. But something is changing. Today, a new paradigm is emerging, one where the tools of science are becoming open, accessible, and shared. Hello, I'm Veena Marlena, a researcher passionate about open science and the idea that knowledge should not be restricted. Welcome to Open Access Tools for Physical Sciences, a series dedicated to exploring powerful, freely available tools that are shaping modern research. This series is part of the Physical Sciences Consultorium, PSC, an initiative aimed at bridging the gap between curiosity and capability in science. Because science should not be limited by access. It should be driven by inquiry. If you speak to students entering research today, a common perception emerges that high-level simulations need licensed software. That meaningful research is inaccessible without institutional backing. And historically, that perception was not entirely wrong. Many of the most widely used scientific tools have been locked behind paywalls, making them unavailable to a large section of aspiring researchers. This creates an invisible barrier, not of intelligence, not of effort, but of access. But over the last 2 decades, a quiet revolution has been taking place. Scientists, developers, and communities across the world have been building open access tools, tools that are freely available, transparent, and continuously evolving. These tools are not inferior alternatives. In many cases, they are at the core of cutting-edge research. And one of the most important among them is Python. Python is a programming language, but describing it that way is almost an understatement. In the context of physical sciences, Python is not just a language, it is a computational environment, a research framework, and increasingly, a scientific medium. It allows scientists to translate ideas into computation, to take equations and turn them into simulations, to take data and extract meaning from it. Consider a few possibilities. A physicist studying motion can simulate trajectories. A researcher analyzing radiation data can process and visualize patterns. An astronomer can analyze signals from distant objects. All of this can be done using Python. Through libraries like NumPy for numerical computation, Matplotlib for visualization, SciPy for scientific algorithms, Python becomes a bridge between theory and experiment, between abstract models and observable results. Today, Python is used in large-scale physics experiments, astrophysics data pipelines, machine learning models for scientific discovery, computational chemistry, and materials science. It is not an alternative tool. It is part of the infrastructure of modern science. But beyond its capabilities, Python represents something deeper. It represents a shift in how we think about knowledge, from closed systems to open ecosystems, from restricted access to shared capability. In many ways, open access tools are democratizing science. They are making it possible for someone with curiosity and discipline, regardless of background, to participate in meaningful scientific work. As a young researcher, I strongly believe that science should not be confined. The tools of discovery should not be privileges, they should be possibilities available to all. Open access is not just a technical choice, it is an ethical stance. It is about ensuring that knowledge flows freely, and that the next generation of researchers is not limited by access. In this series, we will explore many such tools, each playing a role in shaping modern physical sciences. From quantum chemistry to space science, from data analysis to simulation, these tools form the invisible backbone of research today. Initiatives like the Physical Sciences Consultorium, PSC, are working toward this vision, creating awareness, building bridges, and making science more accessible. If you believe that science should be open, inclusive, and empowering, I encourage you to support and engage with such initiatives. If you found this perspective valuable, consider subscribing to PSC for more insights into the tools shaping modern science. In the next episode, we explore another powerful open access tool, one that brings quantum chemistry within reach. Until then, stay curious.